Okay, let's dive into a world that's right under our noses but totally invisible. A hidden reality where the rules we live by get thrown right out the window. And, well, pretty much everything you think you know about how the universe works is wrong. See, in our world, things are simple, right? A car is either moving or it's parked. A choice is either yes or no. But when you get down to the quantum level, the universe just refuses to make up its mind. A single particle can be both moving and standing still at the same time. And yeah, a cat can be both dead and alive. Now, that's not a riddle. It's our first clue that we're dealing with a much, much deeper reality. The secret to all this madness is a seriously mind-bending idea called superposition. It's kind of the first rule of this weird hidden world. And it basically says that the tiniest bits of our universe don't have to pick a lane. They exist in all possible states at once, until the moment we look at them. This right here, this is where our journey into the wild world of quantum physics really begins. You know, for centuries we thought we had the universe pretty much figured out. We had this beautiful, predictable, clockwork set of rules that could explain a falling apple just as well as a planet circling the sun. But when we started looking really, really closely at light itself, a tiny crack appeared in that perfect picture. A mystery that was about to shatter everything. Those old rules, we call them classical physics. Think Isaac Newton, that kind of stuff. It's the physics you see every day. A ball rolling down a hill, gears turning in an engine. It's amazing at explaining all the big things we can see and touch. It's logical, it's reliable, it just works. So you gotta ask, right? If these laws were so perfect for predicting everything from cannonballs to planets, why did we need something new? What was the one tiny little observation that brought this whole beautiful system crashing down? Well, that crack in physics showed up with a simple-sounding experiment called the photoelectric effect. Scientists saw something really strange happening when they shined light on a piece of metal. It was one of those things that, according to the old rules, should have been super easy to explain. But it wasn't. It completely defied them and basically sent the entire world of physics into a total crisis. So here's the puzzle. You shine light on metal, and it can knock off these tiny particles called electrons. Now, common sense says that a brighter, more intense light should have more energy to do the job, right? But here's the crazy part. Experiments showed that a dim blue light could knock electrons free, but a super bright, blinding red light did absolutely nothing. It was the color of the light that mattered, not how bright it was. And that just made no sense at all. And then along comes Albert Einstein with this totally radical idea. He said, what if light isn't a continuous wave? What if it's actually a stream of tiny energy bullets he called quanta? Suddenly, it all made sense. The blue light's quanta were like high-powered bullets. Each one had enough kick to knock an electron loose. But the red light's quanta were like weak ones. You could fire millions of them, make the light super bright, but not a single one had the punch to do the job. Light was a particle. And just like that, with that one incredible idea, quantum physics was born. So, with the old rule book thrown out, we needed a whole new one for this fundamental level of reality. And let me tell you, the laws of the quantum realm, they aren't just different, they are profoundly, beautifully weird. Okay, let's start with something super obvious. In our world, if you try to walk through a solid wall, you're gonna get a headache. You just can't do it. But in the quantum world, a particle absolutely can. Without enough energy to go over the wall, without breaking it, a particle can just show up on the other side. They call it quantum tunneling. And that's really the heart of it. For us, a wall is a hard stop. But for a quantum particle, it's more like a suggestion. You see, its location is all about probability. And there is a real non-zero chance that its location will suddenly be on the other side of that barrier. It doesn't smash through, it just sort of stops existing on one side and starts existing on the other. It's wild. And this isn't just some weird party trick for particles.
Quantum tunneling is literally the reason our sun shines. It's what allows protons in the sun's core to get close enough to fuse together, releasing the unbelievable amounts of energy that power, well, everything in our solar system.
Now, a level of weird this good, you just know scientists can't keep it to themselves. So it's really no surprise that these mind-blowing ideas have leaked out of the lab and gone straight to Hollywood, shaping some of the biggest movies we've ever seen. Think about Doctor Strange, right? When he looks into millions of possible futures to find the one path to victory, that's not just some cool idea a writer dreamed up. The seed for that idea comes directly from quantum mechanics. It all starts with that cloud of probabilities we were talking about. A particle isn't in just one spot. It exists in all possible spots at once. So the many worlds theory basically takes that and runs with it. It asks, what if every single one of those possibilities actually branches off into its own separate universe? A universe where the particle is here, another where it's over there. And that's the science behind Doctor Strange's multiverse. Okay, let's switch gears to time travel and the classic problem every time travel movie has to deal with, the grandfather paradox. You know the one. If you go back in time and stop your grandfather from meeting your grandmother, you'd never be born. But then, how could you have gone back in time in the first place? It's a total brain melter, and it's something Avengers Endgame had to solve. And their solution was pure quantum thinking. Instead of one single timeline, they treated time like a branching river of probabilities, an idea from a physicist named David Deutsch. So when they traveled back, they weren't changing their own past. No, they were creating a whole new branch, a new timeline. The genius part, of course, was the fix. By returning the stones to the exact moment they left, they basically snipped off that new branch, stopping it from creating a whole new chaotic reality. But quantum physics isn't just for sci-fi movies anymore. By actually learning to control these bizarre rules, we are building a future that, not too long ago, really was science fiction. I mean, look at this stuff. Quantum mechanics is the key to so many game-changing technologies. We're talking quantum computers that can solve problems that would take a normal computer millions of years. Communication systems that are, by the laws of physics, completely unhackable. Not to mention clean energy and, of course, a fundamentally deeper understanding of the universe itself. And that's really the big prize here, isn't it? This isn't just about cool new gadgets, it's about perspective. By having the courage to explore the smallest, weirdest, most counterintuitive pieces of our reality, we actually get closer to answering the biggest questions of all. How did the universe begin? And what's our place in it? Which, of course, leaves us with one last huge question. The world we see every day, the solid, logical, predictable world, is all built on this chaotic, probabilistic, and just plain weird quantum foundation. So if this is the reality that's been hiding in plain sight all along, what other incredible secrets are we still missing?